Let's take a look at this example. This time we have two components in parallel, diode and resistor. You're supposed to be very careful with this kind of problems. Many students make mistake and say, okay, so the voltage across the resistor is equal 0.7 volts. This is not always true. First, okay, we are going to make the test for the diode in order to solve this problem correctly. We have to make sure the diode is in the on state or maybe is in the off state. Everything depends from the voltage across the resistor R2. So what we're supposed to do first, at the very first moment, right, we're supposed to forget about the diode. And by using voltage divider formula, we're supposed to find the voltage across resistor R2. So forget about the diode at this moment and we have series circuit. Find the voltage across resistor R2 using voltage divider formula. So I have V R2 is equal voltage source times R2 over R1 plus R2. Don't forget that we're at this moment ignoring the diode. Okay, the diode is at this moment not existing. So we have voltage source equals 6 volts. R2 is equal 1 kilo. And I have R1 equals 3.3 kilo plus 1 kilo. So VR2 is equal 1.39 volts. Okay, so this is the voltage across the resistor R2 when the diode is ignored. So what it means for us? It means that the diode at this condition, right, is conducting. If VR2 is greater than 0.7 volts, right? If VR2 is greater than 0.7 volts, it means that the diode is in the on state. The voltage across the diode is sufficient to turn on the diode. Okay? The voltage must be greater than 0.7 volts. So it means that VR2, don't forget it was the test. Okay, so it means that VR2 is equal 0.7 volts. Okay, now I'm talking of the situation when the diode is back in the circuit. Okay, so we just proved that the voltage without the diode across the resistor is going to be greater than 0.7 volts. So it means that the diode is going to turn on if you are going to replace the diode, and the voltage is not going to be over here and 1.39 anymore. Is going to be 0.7 because the diode is taking over. Okay, so VR2 is equal 0.7 volts. Please notice that the output voltage is voltage taken from the resistor, right? And also from the diode because they are in parallel. So I can say that Vout is the voltage across silicon diode. So I can say that Vout is equal VR2, and this is also equal V diode, right? V silicon, and this is equal 0.7 volts. Next, we're supposed to find VR1. In order to find VR1, I can write the KVL equation. Okay, so my current is going to be pushed in this direction. So I have positive sign, negative, positive, negative. Okay, and we said already that the diode is going to conduct because the direction of current is matching the direction of the arrowhead in my diode symbol. So we can write the KVL equation for the circuit, right? We're going to talk about this loop only because we're looking for the voltage across resistor R1. So I have negative, because this is my negative terminal, this is positive, voltage source plus V R1 plus V silicon is equal 0 volts. So if you are going to solve this formula for VR1, you're going to have VR1 equals voltage source minus voltage at the silicon diode, where voltage source is equal 6 volts minus 0.7 volts. This is equal 5.3 volts. Okay, so this is voltage at resistor R1. Next, we're supposed to find the current which goes through resistor R1. I R1 is equal VR1 over R1, where VR1 is equal 5.3 volts and R1 is equal 3.3 kiloohms. Everything is equal 1.6 milliamps. Okay, so this is the current which will go through resistor R1. And please notice that this is going to be also equal to I total. I R1 is equal to I total. Next, we're supposed to find ID. But in order to find ID, you're supposed to find first IR2. IR2 is equal VR2 over R2. We said that VR2 is equal 0.7 volts. So I have 0.7 volts divided by 1 kilo ohm is equal 700 microamps. Okay, so this is the current IR2. If you want to find ID, the current which goes through the silicon diode, we can say ID or ISI. This is nothing else, just the difference, right, of I total and IR2, because I total is going to come to this point and is going to split, right, into two currents, ID and IR2. So in order to find ID, I'm supposed to simply write I total minus IR2 is going to give me ID. So if ID is equal I total, and we said that I total is equal to IR1 is equal 1.6 milliamps. So if 1.6 milliamps minus IR2, and IR2 is equal 700 microamps. So have ID is equal 900 microamps. Okay, so this is the current which goes through the diode, ID. So as you can see, we solved the problem.